Yes, students, today we'll go for analog to digital converter interfacing. See, these are the topics which are very helpful for your future classes. But these topics, many of the students, you will fail to attend. Interfacing of digital to analog converter, analog to digital converter using parallel ports of 8051. So what does this mean? What do you mean by analog to digital converter? First let us understand. So if you are taking this analog input, how the digital output you will be getting, first let us see, and then this analog input to convert into a digital output, what type of converter we have to use, what are the different types of converters we have, internal circuitry is what. Say for example, most of the real-time applications are your voice signals or your video signals, and these speech signals, when they are occurring in real time, they will have the continuous amplitude variations with respect to time. Whichever the signal which is varying its amplitude with respect to time continuously are termed to be the analog signals. Such an analog signal, your computer, when you want to feed it for the analysis, it is not able to accept this information because it is not able to understand. Then how do this particular computer can be made to understand this analog information? There we will come across the analog to digital converter. When this analog to digital converter it is used, such an analog continuous analog signal will get converted into streams of zeros and ones, and which this particular computer is able to understand. So hence, whenever any data or any real-time applications, when they needs to be understood by the 8051 controller, then what is required here? We require an analog to digital converter. The function of this analog to digital converter is to take the time varying signal, continuous time varying signal, convert that signal into discrete signal, discrete binary signal. Whenever such device we are using for the conversion of a continuous time varying signal into a digital signal, it is termed to be the analog to digital converter. Now, what are the various types of analog to digital converters you have? You have the flash ADC, to which you can give the input as the analog input, and you can see digital output. This is the first type, and the second type of the ADC which usually we will be using is the sample and hold ADC. Okay, analog to digital converter. Then RAM type analog to digital converter, we can make use RAM type analog to digital converters we can make use. And successive approximation ADCs, approximation ADC also we can make use. So there are many dual ramp ADC, you have single slope ADC, you have many types of ADCs you have in the real world, and all these ADCs whenever they take an analog input, they will be taking in the form of discrete signals and converts into a digital output. When the digital output it is converted, these ADC's digital output, sometimes it may be 8-bit output, or it may be 10-bit output, or sometimes it may be single bit output. When 8-bit ADC is considered, the example is 0808, 10-bit ADC 0806. If you go for single bit, this is an serial ADC we will say. So such ADC also we can use in case of an analog to digital converter. But out of these ADCs, which is the one ADC we will be considering for our discussion is 8-bit ADC, that is IC number is 0808. When such, either this can be 0808 or 0809. Any IC, it is of 8-bit ADC only. And again you may get a doubt that this ADC, whether it is of successive approximation or RAM type or sample hold or flash ADC, always what we have used this 8-bit ADC for our analysis purpose is an successive approximation ADC, SAADC. Okay. So what is this successive approximation ADC means? How this particular ADC will function? So you can see, look at this, because you can see this 808 as an IC, but that IC inside internal structure will be an comparator. Comparator has been designed with op-amp, and this op-amp, okay, this is positive and this is negative. This op-amp will get an another input as from digital to analog converter, but for this digital to analog converter, the input will be derived from a register, and this register will be an successive approximation register. So there will be n number of bits input that will be coming from this register, but this register input will be from an analog output after converting, after giving it to an memory element, or what is that, we'll say ADC comparator sample and hold. Okay, sample and hold circuit we'll be using. Now output of this sample and hold circuit will be given to an a register, and this register output will be the digital output of n bits we will be considering. This is an actual circuit diagram, and the analog input we will be giving for this particular terminal, and this is how where analog to digital converter we will be designing in case of successive approximation analog to digital converter structure. Okay, such a IC, which assume that it is available for your interfacing with the 8051 IC 0808 or 0809. It is both are 8-bit ADCs only, and they will be functioning as taking input as an analog input and giving an output as digital output. Now, how to interface? First, let us see how this 8051 will get interfaced with 0800. Sorry, 0808. So, assume that you have an analog to digital converter. So, this analog to digital converter sometimes will be never you will have a single channel. You can see 8 channel ADC. 8 channel ADC means it will support for 8 different inputs. So 1, 2, 3, 4, 5, 6, 7. Input 0, in 1, etc. in 7. Totally 8 inputs of analog in nature can be given for ADC. And the output, as we know that it is a digital output, it is of 8 bits, D0, D1, etc. up to D7. They are all given to an port, whichever the port you can consider of 8051, you can consider it may be port 0, port 1, port 2 or port 3, but preferably we'll go for port 2 or port 1. So whenever it is connected to port 2, port 2.0, port 2.1, etc., port 2.7. And when this input to an 8051, any port it comes, the input is an analog input and the output is an digital output that will be interfaced to the 8051. So the 8051 can easily understand the information. But when this ADC is considered, there are 8 channels. Input may be connected or analog input may be connected to any of these input channels. In such scenarios, how do this particular ADC will choose the analog inputs, a respective analog input? For that, let us further consider this 808 in little more in detail. Ground, there is a clock, then VCC, it has VCC also to be connected to function, and its importance, why that VCC it is connected, its importance you will study in VLSI design, but that is not appropriate to discuss at this point. So you will have start off conversion, you will have V reference minus, because comparator means you can see there is a positive reference voltage and the negative reference voltage. Then you will have 3 inputs which are termed to be ABC, because using these ABC, which channel of the input that is to be connected for ADC will be decided. Okay, then there is one outgoing pulse, that is here end of conversion. So all these are connected to one of the port of 8051. Let that port be port 3.x. Some pin has been connected for this. Okay. Now this will be the circuit diagram which will be used for interfacing the 8051 with analog to digital converter. Now let us see how a program will be written for this particular analog to digital converter. So these ADCs, where they'll be used? They'll be used only when an analog signal to be converted into digital. These will be used. So whatever the ADC which we have chosen, it is an 8-channel ADC which will have 3 address lines to select the appropriate input channel, and then there is an ALE signal too. So this ALE signal which is connected to the 8051 ADC from the 8051 through some port 3.x will make this ADC to get enabled. That is a function of this ALE. And similarly, there is one more pin which is associated with this ADC, that is the OE bar. This OE will enable the chip, provided it will be connected to 1. And here V reference plus and V reference minus. V reference plus is at plus 5 volts and V reference minus has to be grounded. So whenever V reference plus it is connected to 5 volts and V reference minus it is connected to 0 volts, that is V reference plus, and if it is at plus 5 volts and V reference minus if it is at 0 volts, range of input analog voltage which get converted converted into digital is a maximum of 5 volts. Okay, so this 0 volts refers to all the 8 bits as 0 0 0 0 0 0 in binary, and 5 volts will be into 1 1 1 1 1 1 1 1 in binary. Okay, so now when these references are considered and ADC is connected to the 8051, whenever and after that, after the connectivity or connection it is completed, when a voltage is applied, the ADC should start converting the given analog input voltage into its equivalent digital output, and it has to give it to 8051. So for which the program has to be written. Whenever we are writing the program to perform this operation, the 8051 should execute the instructions step by step. First, what it has to do, it has to select the channel, it has to give the start of conversion pulse, and then it has to monitor whether the complete conversion process has been completed or not, and then it has to end. Once the end of conversion it is finished by the ADC has to send a signal to the 8051 stating that the conversion process of a given analog voltage has been completed, so the digital data is ready. That indication will be provided through end of conversion pulse. So EOC is end of conversion from ADC to microcontroller, and start of conversion it is from microcontroller to ADC. Then after this, ABC are used to select channel. Okay, ALE to latch the address. Okay, so now with all these notations, how do we write a program to perform this operation? For which, let us see ORG 00H. You know that this is origin of the program. SJump 30H, because of the interrupt vector table, these 30 hexadecimal locations we are skipping. Then ORG 30H. Okay, fine. From there on, you will be calculating, or you will be writing the program for the 8051 to execute and perform the given operation. What is exactly first step that we need to? We have to assign all these start of conversion, end of conversion to specific pins in case of 8051. For that, AD output enable bit, it is connected to P3.6. okay, then AD end of conversion, it is connected to bit P3.3. then AD SOC or start of conversion, or SOC or SC also you can take, bit P3.5. then AD ALE. These are the pin assignments we are doing for 8051 pins P3.4. then there are 3 address lines, AD0, AD1, AD2. Those are represented as A, B, C in case of chip. So these also needs to be assigned to bits. So therefore you can say that AD0 bit assigned to P3.0, P3.1, P3.2. Okay, after that, your program has to run. So therefore, all initializations got over. Now, make the port 2 to port 2 to input port, configure port 2 as input port. So by sending FF to port 2, so therefore move P2 comma #0 FFH. After that, what we need to do? We need to set the start of conversion or end of, we have to send the start of conversion pulse. So move. Okay, before that what you can do, 1 minute, after sending move P3 dot #08. So check P3 dot 3 as input, whether already the 8051 has sent an end of conversion or not. If it is so, so you can, if it is not, then CLR RP3 comma #08H. Okay, then clear AD/ALE. See what exactly this program is. You can go through the program. Let me, 1 minute, students. Okay. If you look at here, this process is very simple. It's getting hanged up, so wait for a minute. The process is very simple. Send all the control signals between ADC and the port pins to 8051, and between 8051 to ADC establish the communication channels. After that, send the start of conversion pulse. Whenever start of conversion from 8051 to the ADC has been sent, ADC will start converting by considering the input from any one of the channel. Once the conversion has been finished, the ADC, it will send a end of conversion pulse to the port 2 of 8051. So by seeing that end of conversion pulse by 8051, what it does, it is going to terminate the operation, or if it has to continue for some more values, it will be continuing. So for which some initializations needs to be done, all the initializations which have been I've already explained, but the program you can go through. Okay, this is the one, and if you go for another type of ADC, please students, you can look at here, because here is an direct explanation I can give you for remaining programs. There is an serial ADC. This serial ADC is an 10-bit ADC. The number is ADC 1031. Here, serial ADC means ADC will convert 10 bits output, but its output which is going to 8051 is of only 1 bit. So in such cases, how do the design will be, for which ADC 1031 and 8051 you can look at here, which are represented within the block diagram, how they have been connected. From ADC, there is only one pin, that is D0 pin, which is connected to 8051 to carry the or to convey the data information or the digital data information. Since a single bit it is going to convey the information or digital information to 8051, it is termed to be an serial analog to digital converter. Other important pins which are with respect to this serial in ADC interfacing is as shown here. P3.5, it is an serial clock connector to ADC 1031. Similarly, P3.7, it is chip selection bar pin. So unless this 8051 sends a active load on P3.7, the 8050 ADC can't start its conversion. There is no start of conversion or end of conversion here. Just it will be only a single input that is going to be read by 8051 from the ADC, but this ADC will make use S clock as well as C clock. Okay, crystal clock 1 and serial clock 1 will be providing. So relevant to that particular block diagram, a program has been written here. Please go through. First try to understand this particular. As per this diagram, the program has been written for digital to analog converter, which is of serial in nature. The next important interfacing board is our stepper motor. This stepper motor, we know that it will rotate by itself in terms of step angles. The 360 degrees rotation or the complete 360 degrees rotation has been divided into the different step sizes in stepper motor. Almost 200 step sizes will be taken or steps will be taken to complete by this stepper motor to finish one revolution. So hence each step angle, if you are calculating 360 divided by 360 divided by what is that? It is a step angle we are calculating, no? Step angle, it is 360 degrees divided by the 200 steps. If it is calculated, almost it is going to be computed as 1.8 degrees. Or the stepper motors which are available in the market, they will act as an stepper motors with a step angle size, varied step angle sizes, which are shown here as mentioned. 1.8 degrees step angle stepper motor also you have, 7.5 degrees stepper motor also you have, 15 degrees stepper motor also you have. For example, if the step size or step angle is 1.8 degrees, then 360 degrees to cover with this step angle, it is of 200 steps. If stepper motor rotates with 90 degrees, then step angle is 90 degrees. And how many rotations, how many steps it will take? 4 steps only it will take. If it is rotating at 45 degrees, then how many rotations? It is 360 divided by 45. Those many steps will be taken to complete the stepper motor in to step the angles. Now, how do this type of stepper motor will interface? Let us see now its block diagram, stepper motor interfacing block diagram. The stepper motor usually will have 4 coils, coil A, coil B, coil C and coil D. This is what the stepper motor is. From the port of any port of 8051, these stepper motor coils needs to be energized. Then only this motor will start rotating it. Then how do we energize these step angles or coils in stepper motor? That is what here it has been described. So all the 4 coils, you can see here one what is that? 4 transistors we have connected, and these 4 transistors which in turn are connected through the ports. Some of the port pins you can make use. Here we have used port 2, port 2.0, port 2.1, port 2.2, port 2.3. These port pins directly which have been connected to the stepper motor coils, and these coils are represented as A, B, C, D. During the connectivity or energizing the stepper motor coils, the coils have to be energized in this particular manner only. A coil, B coil, C coil, D coil. These are all the magnets. Usually the stepper motor will be designed with these permanent magnets. And as we know, the magnet property is that when like poles occurs, they'll repel, and when unlike poles, they'll start attracting. With this basic principle, the stepper motor coils has to be energized to make the step angle or the stepper motor to rotate clockwise or anti-clockwise. Okay. So now the stepper motor, as we know that it can be rotated in the forward direction as well as in the backward direction. By energizing the various coils, if suppose coil A is kept at high and if coil C is kept at 0, then the deflection meter which is present in the center will start reflecting towards the C. If C is made north and B is made 0 south, then this will get reflected to here, and so on. That will be the process that we will be using to make the stepper motor to rotate. Students, here is the program to rotate the stepper motor either in the positive direction or in the negative direction. So what the energizing coil code you need to send, that you can send it through port 2. As port 2 pins have been connected to the stepper motor, so therefore move P2 to 03. With 03, a call delay, small delay you can provide. Again, next energizing coil of 09 you send it. Call the delay, energize the stepper motor with 0C value, so that the coils will get energized, and based on that the stepper motor will come out from the earlier position to the next position, and so on. So there is a small delay also you need to provide. Interfacing of DC motor, as it is not covered in your syllabus, so I am not going to continue that particular, or I am not going to execute that particular DC motor interfacing. So students, these are the various interfacing boards you have. Let me verify with respect to your syllabus, and then we'll say what are the topics which we have left to discuss in next class. So we use syllabus. So you can see here module 4 almost it's completed, everything except C programming, that is the one pending topic we have. And here you can see ADC, DAC, LCD, stepper motor. ADC, DAC and stepper motor we have finished. We have to finish LCD, and this interrupts programming. So C program to transmit or receive the data serially. Then what is the next topic that we are supposed to discuss? It is an LCD. Apart from that, there is no keypad interfacing or anything such big programs which have not been included for your syllabi, whereas your seniors, they had all those things. Almost 300 lines code we need to learn for an